Hello, in this mind map, we are going to focus on what tumors actually look like, so morphology of tumors, and we're going to look at both gross as well as microscopic morphology. So as always, we will classify them into benign versus malignant tumors, and we'll start off by looking at the gross appearance. So let's begin with benign tumors. They are generally fairly well circumscribed. You can see that the edges of the tumors are quite well demarcated. Sometimes they can be quite rounded as well. They may be encapsulated, not always, so there may be a nice well-defined fibrous capsule around tumors sometimes, for example in follicular adenomas in the thyroid, and they're often quite rounded as mentioned. Here is an example of a leiomyoma. This is a benign smooth muscle tumor arising in the smooth muscle wall of the uterus. Here is the endometrial cavity which has been compressed. This is the uterine cervix, and we see a very well demarcated, not encapsulated, but well circumscribed oval tumor which is quite solid and fleshy. There is no evidence of any irregular or infiltrating growth into the wall of the uterus. Also, much of the time, we tend not to see so much evidence of hemorrhage or necrosis in benign tumors. These are generally not seen. Occasionally, we can have hemorrhage, but usually not necrosis, because necrosis usually occurs in tumors that are rapidly growing. Now, in contrast, malignant tumors tend to be more irregular. Some of them may be very well demarcated as well, but they're not as rounded. They are generally not encapsulated, and we may see hemorrhage or necrosis on the cut surface. So necrosis would be recognized as a paler area within a fleshy tumor. Here is an example of a carcinoma arising in the cervix of the uterus. So we have two uterus specimens. Just now we had a benign tumor arising in the wall. This is the endometrium, this is the myometrium, this is the uterine cervix. We can see here quite an irregular tumor. It is not very well demarcated in this case. It's certainly not nice and rounded like the previous tumor. There are areas of hemorrhage and some cavitation as a result of necrosis, and this is carcinoma of the uterine cervix. The most common histologic type would be a squamous cell carcinoma. Additional things to look for would be the presence of enlarged lymph nodes in malignant tumors, because we know that they can spread, and they tend to spread first to the regional lymph nodes. So not only may they be enlarged, they may be matted, meaning that they may be stuck together. Sometimes this is palpable, depending on where the tumor is. Also, the tumor may invade into adjacent organs, so it may adhere to adjacent organs, and this is generally not a good sign, because we will be worried about locally advanced tumor. Now, when it comes to microscopy, there are also several clear differences, both in terms of architecture as well as the actual morphology of the nuclei. So we're going to take a glandular tumor as an example, just to illustrate microscopic morphology. And if you remember, adenoma is a benign gland-forming tumor, and adenocarcinoma is malignant gland-forming tumor. So let's have a look at a benign gland-forming tumor, what the cells would look like. Generally, what we would see would be the glands are very well formed, so they're usually quite nice and rounded. The nuclei of the cells tend to be polarized and basal. By this we mean that they are sort of close to the basement membrane of the gland, with a column of cytoplasm above it. And you can see that most of the nuclei still maintain their basal location. So this means that they maintain their polarity. They are of generally uniform size and shape. We don't get a lot of variation in size and shape. We tend not to see a lot of mitosis, and generally there is no necrosis. So in contrast to this, if we were to look at an adenocarcinoma, which is a malignant gland-forming tumor, the glands would generally be a lot more irregular as compared to these nice, rounded, uniform appearing glands. First off, we will see irregular, poorly formed glands. and these would have already invaded through the basement membrane of the original glandular structure and gone and invaded into the stroma. So the stroma does not like this, does not like to have tumor cells crawling around, so it then generates a stromal reaction with some fibroblasts, and this stromal reaction is known as a desmoplastic stroma or desmoplastic stromal reaction. Now, looking at a more close-up view of the actual cells, we'll focus on the nuclei because this is where we will see features of malignancy. So we can have cells that are quite variable in size and shape, and this is termed pleomorphism. So there is nuclear pleomorphism, large nucleus in one cell, smaller nucleus in another cell, and they look quite different. So some of the features that we would encounter would be enlargement of the nuclei, irregular nuclei or irregular nuclear membranes, prominent nucleoli as you can see here and here, mitotic figures, as well as the presence of abnormal mitotic figures. I've tried to draw a mitotic figure here, but you should try to recognize them on microscopic sections. Some of the talking slides will illustrate them. There is also usually an increased nuclear cytoplasmic ratio, meaning that nucleus appears bigger relative to the whole cell size. There is loss of polarity. You can see that in this gland, some of the nuclei are right up against the lumen, whereas others are more basal. So it's up and down, this kind of almost stratified appearance. The nuclei are hyperchromatic, so the chromatin appears dark, and generally the chromatin is very coarse and sometimes clumpy. In addition, there may be invasion into blood vessels and lymphatics, as well as adjacent organs, and also we may see tumor necrosis, and this is because in malignant tumors they grow much faster than in benign tumors, so they tend to outstrip their own blood supply, and therefore the malignant tumor cells will die from ischemia.